Expand and simplify. So we have these terms. We can expand them. Every term needs to be multiplied here. So 5x plus 5 6 is 30 plus 2 7s is 14 minus 2x. Collecting the like terms, 5x take away 2x gives you a 3x, and 30 plus 14 is 44. Factorize fully 9y square minus 15y. So we can take out the numbers and the letters as common here. So from the numbers 9 and 15, we find the HCF, which gives you, the HCF of 9 and 15 is 3. So we take out 3 as common term, and then we can take out one of these y's is common. So what remains will be, so 9y squared divided by 3y is a 3y minus 5. So the answer is 3y of 3y minus 5. Write down the value of 2 raised to 0. Any number raised to 0 is equal to 1, where a should not be 0. So applying the rule here, we get the answer as 1. Ian cycled 44 kilometers in 2 hours and 12 minutes. Work out his average speed. The answer should be in kilometers per hour. So 2 hours and 12 minutes, we have to convert minutes into hours. So you divide it by 60. So that's 1/5. That's equal to 0.2 hours. So 12 minutes is equal to 0.2 hours. 2 hours and 12 minutes would be 2 plus 0.2, which is 2.2 hours. So now that we have time in hours, the distance is in kilometers. The speed will be distance divided by time. So 44 over 2.2. You can get rid of this decimal and include a 0 in the numerator to have 440 over 22. You can divide this by 11. So 11 goes in for 40 times, and 11 goes in 22 2 times. Half of 40 is 20 kilometers per hour. The scatter graph shows the stopping distances for some cars traveling at different speeds. So we have the stopping distances on the y-axis and the speed on the x-axis. It wants you to find the correlation of this graph. So how are the variables like speed and the stopping distances related to each other? So we see as we move on to the speed, as the speed increases, the stopping distances also goes up. So here we see these values are going up as the speed goes up. So it's like a positive relation. So we say the correlation is positive. Another car is traveling at a speed of 55 mph. Estimate the stopping distance for this car. So if the car is traveling at 55 mph, so 55 is between 50 and 60 here. So somewhere here we can estimate the stopping distance to be maybe 61 or 62. So here I see there are all these points. So to match that, like if you draw a line of best fit here, it needs to match somewhere here. So maybe like 62 or 61. So if I go with 61 meters, well, your answer could be slightly different. So like plus or minus 5 meters should be accepted here. Sanar says it would not be sensible to use the scatter graph to estimate the stopping distance of a car traveling at 10 mph because the estimate would not be reliable. Is Sanar correct? You must give a reason for your answer. So Sanar thinks that if we are trying to estimate the stopping distance for a car traveling at 10 miles per hour, that means somewhere here, the answer would be not reliable. Is he right? I would say yes, because we are like trying to go out of the scope of the graph. So the point ends here. And if we are trying to estimate the stopping distance somewhere here, it's like we are trying to use extrapolation here. So the answer would not be reliable. So I will say yes, he is right. Sorry, this is 61. So this is yes, because 10 mph is like out of scope of graph. So any estimate would not be reliable. The next question is, there are 4 containers with like different shapes. Water is poured into the containers at a constant rate. The sketch graphs below show the depth of water in each container t seconds after the water starts to be poured. So these are the graphs, and you need to match these graphs to the containers. Now, how can you match them? The graphs is dealing with like the depth and the time. So how is the depth and time related? Or in other words, if you are pouring water in these containers, how are they like how much time does it require for them to be filled? We need to try to find some relation here. So we know if the bottom, or if any container is like narrow, like if the narrow thing is there, then if you pour water, it will be it gets filled quickly. So if it's getting filled quickly, it takes like less time. And if the container is wide, it takes more time to fill the water level. Okay, so using this like this understanding, now what can we say about the containers? Container A seems to be like it's a so the base and the height has like the constant relation here. So if you're pouring water here, they get so it takes like the constant time to increase. So here I would say this linear graph matches with this for container A. So I'm going with graph 3 for container A, because it's like the rate of change of the water is like constant here. For container B, here we see the depth is a little wider, and then it gets narrower here, and then to the top again it gets wide. So this is wide, this is narrow, and this was a bit wide. So if it's wide, it takes more time. So which of these graphs, like if it's taking more time, this time is 0, the time is 0, here time is like little more than 0, and then it gets like little lesser, and then again it rises. So I would say container B is matching graph 4. The next container is C, where we see the bottom is narrow and then it widens up. So if it's like in the beginning, it will take less time and then it goes up. So less time and then goes up constant, like it increases, it keeps increasing. So this is kind of like exponentially. So I will say it's graph 1. It's kind of like exponential increase. And then last container D, well, we are left with only graph 2 here, so we can just say it's this graph. All right, the next one is the diagram shows a rectangular wall 10 meters by 3.3 meters. A rectangular door in the wall is 2 meters by 1.5 meters. Zach is going to mix yellow paint and blue paint in the ratio 1:4 to paint the wall. He will not paint the door. So this part is not painted. He needs to exclude this. He assumes that 1 liter of paint will cover 10 meters square, and then he has all these costs. So we need to first understand here, there is this wall with some dimensions. If we can find the area of this wall and exclude the area of the door, we will get to know the area he needs to paint. Okay. And then with the assumption he has and the cost of these tins, he has yellow tin and the blue tin cost, and he has got 20 pounds. We need to figure out if we've got enough money to paint the wall. So to judge if he has enough money, we need to first find the area of the wall. So the dimensions are 10 by 3.3. So that's a 33 meters square. And from that, you need to exclude the area of the door, which is 2 times 1.5. That's a 3 meters square. So 3 take away from 33 is 30 meters square. So he needs to paint 30 meters square area. And 1 liter covers 10 meters square. So 30 meters square, he will require 3 liters of paint. He needs these two colors, yellow and blue, in the ratio 1:4. So yellow and blue in the ratio 1:4 needs to be mixed. So he has total 3 liters. In this ratio, he will have to divide it in like 5 parts. So yellow paint, so 3/5 is like 0.5, 0.6. So he will need 0.6 liters of yellow paint and 3/5 times 4. So that's 12/5. So I will say like, so this is 6. So 6, this times 4 will be 2.4 liters of blue paint is required. Well, we see the paints are getting like, you get them in liter tins. So he cannot have like 0.6 liters. He needs to buy 1 tin at least to cover yellow paint. And for blue paint, he needs like 2.4 liters. So he will need 2 liters and plus 0.4. So he needs to have 3 tins of blue. So 1 liter of yellow will be 4.75, and 3 liters of blue, you need to times it by 3. So that's 3 5s is 15, 3 5s 15 plus 1 16, 16.5. So the total cost he will need for both the colors will be 12, so 6 and 11, 21.25. But then he has only 20 pounds. So we just have to tell if he has got enough money. So we will say no, he needs 21.25 pounds to paint the wall. So he doesn't have enough money. Now Zach's assumption is wrong, and 1 liter of paint will cover more than 10 meters square. How might this affect your answer to part A? You must explain your answer. So now if his assumption that 1 liter will be sufficient for 10 meters square is wrong, and he can cover more area now. So if he's covering more than 10 meters square, that means he will require less paint. So we will say he will need lesser than 3 liters of paint to cover the area he needs to paint. But then we cannot say for sure by how much less or by how much more area will it cover. So will the amount be still sufficient for him? We can't say that for sure. But one thing is sure, that he will need less paint to cover the area. So we will say, how might this affect the answer? The answer will be, he will need still less paint for the wall. But we cannot say anything about the amount, so I'm not commenting anything about the amount. Well, the diagram shows 2 quarter circles with the same center. So there is this center, there is this small quarter circle, part of a quarter circle, part of a circle which is quarters here. And this is the part of a larger circle, the quarter part of a larger circle. Work out the area of the shaded section. So this gray area, you need to find the area for this. Now, how will you find the area of the shaded region? You can find the area of the smaller quarter circle, area of the larger one, and if you subtract them, we will have only this part of the area, or the area of the ring. Okay, so here we can start with area of the larger quarter circle. Large quarter circle will be, now we know the area of circle formula is pi r square, but if it's a quarter circle, you need to divide it by 4. So for the large circle, the radius is 4 centimeters, so that will be pi times 4 square divided by 4. So that's the 16 pi over 4. Now I'm not going to simplify it. I'm keeping it as it is. So because it wants the answer in terms of pi, so let that be. So area of smaller quarter circle will be pi times 3 square over 4. So 3 square is 9 pi over 4. And to find the area of this shaded part, or the area of the ring, here will be 16 pi over 4, take away 9 pi over 4. Since we have the same denominator, we just have to subtract the numerator. 16 pi take away 9 pi. So that will be a 7 pi, right? The answer is 7 pi over 4. The line L is shown on the grid. Find an equation for L. Give your answer in terms of y is mx plus c. So equation of a straight line in the form y is mx plus c tells me that m is the gradient or the slope of the line, and c tells you about the y-intercept. So y-intercept is where does the line crosses the y-axis. So here we see the line is touching or crossing the y-axis at this point at -2. So the y-intercept is a -2. We have to figure out the gradient. How is the line sloping? So to find the slope of the line, we need to figure out how much is the rise over run. So if we take any two proper points on the line, so let me use another color here. So suppose if I'm taking this point and the point on the intercept here, and if I try to connect them making it like a right angle triangle, and then figure out the distance here. So the rise here is like each of these is 2 units. So 2, 4, 6, 8, 10, 12. So that's 12 units up. And there is, so each of these is like 1 unit here. So 4. 12 over 4. But then we see the line is sloping downwards here. So that's a decreasing line. So this will be a negative slope. So 4 goes in 12 3 times. So a slope is -3. So we got the negative, we got the gradient as -3. The gradient is -3 and the y-intercept is -2. Substituting these values in the equation, we get y is m, which is -3x plus a -2. Well, you can write it in a little better way. So to plus and minus altogether, we can just write it as -2 here. So that's the equation of the straight line. Duane buys 20 rulers for 40p each. Duane sells 15 of the rulers. He sells each ruler for the same price. He makes 50% profit on the price he paid for all 20 rulers. How much Duane sells each of 15 rulers for? So he bought 20 rulers for 40p each. So the cost of 20 will be 40 times 20, which is 800p. So let me keep it as p because it wants the final answer also as in terms of p. So 800p is the cost price of all 20 rulers. And he sells 15 of the rulers for the same price as he, so each of the 15 rulers is sold with the same price. He makes 50% profit on the price he paid for 20 rulers. So what's 50% of 800? So we know 50% of 800 is 400. So adding this 400 to 800 will be 800 plus 400 is a 1200. So he is selling 15 rulers with a price of 1200. That's the selling price. So work out how much he sells each of the 15 rulers. So he's selling 1200. He's selling 15 of them with 1200 price. So one of them would be how much? So 1200 divided by 15 gives you the cost of one ruler. So this is like 3 5s is 15. 3 goes in 12, like 3 4s is 12. So 580. So it's 80p. He's selling one ruler for 80p. Let me make it slightly larger so that it's more clearly visible. Now the table shows information about ages in months of the children in a nursery. So all this information is given. You need to draw a box plot for this information. So we've got the median, we have got the upper quartile. We don't know the lower quartile, but the range is given here. So using the range, we can find the lower quartile. Interquartile range, you can use the lower quartile. And also we have got the range and the least value. From this, you can find the highest value also. So starting with the highest value, so the range is 7, least value is 7 and the range is 25. So when you add this, you get the higher upper value. So higher value will be 7 plus 25, so 25. 32 is the higher value, right? And with the upper quartile, you have 29 and the range is 15. So the upper quartile is 29 and the range is 15. So what is the lower range? Sorry, let me write it like. So upper quartile minus the lower quartile gives you, the range is 15. So from this you get 29 minus 15 gives you the lower quartile, which is 14. So lower quartile is 14. So now we will plot these points here. I can use another color. So starting with the median, which is at 22. So here we have, this is 21, 22. So 22 is somewhere here. All right. Let me make it a little. And then the upper quartile is 29. 29 goes in here. And the lower quartile is 14. So that's 12, 11, 14 is in here. And then I can join them to make the box. And for the least value, which is 7, so 5, 6, 7, that goes in here. And the upper value, the higher value is 32, that's here. So that's a box and whiskers plot. All right, next question. So here we have these vectors. Given that 4a minus 5b is 2c, find the column vector b. So we don't know the column vector b. We can assume it as like x and y to have its values. So 4a minus 5b is 2c. So you times this vector a by 4 to get 4a. So 4 ones is 4. 4 sevens is 28. So that's a negative 28. Minus 5b. So b, I'm assuming it to be x and y. So this will be 5x and 5y. This is equal to 2c. So 2 times 17 is 34. 2 times 19 is a negative 38. So I've made an equation. I have to figure out the values of x and y. Well, I can add this vector on both sides. So adding 5b on both sides. So this, I can get rid of this. And then we have 4 minus 28. And then this is 34 minus 38 plus 5 plus 5x 5y, and then I subtract this 2c on both sides. So to have 4 minus 28 minus 34 minus 38. So that is 5x and 5y. So 4 take away from 34. So that's a negative 30. 28 minus of minus 38 should be plus 10. Right? Right. So this is 5x, 5y. So what should be the value of x and y? So to get x and y, you divide each of them by 5. So here we go. X will be a negative 6 and y will be 2. So the answer is minus 6 and 2. So that's it, 2. All right. Shape A is rotated 90 degrees clockwise about the point -1, to give shape B. Shape B is reflected in the line y is -1 to give shape C. Describe fully the single transformation that maps A onto C. So to describe this, first we need to rotate the shape. So, well, you can use your like the tracing paper to rotate the shape. I'm going to show you how we can do it without using a tracing paper. So the task here is, first we need to rotate shape A 90 clockwise about the point -1. So the point is here. That's the center of rotation to get shape B. So what does 90 clockwise says? So 90 clockwise rotation will be something like this. So I'm showing you the orientation of each and every point here. It needs to be following this order for clockwise. If it's anti-clockwise, it's the other way. So now take every point on this shape A, considering it from the center and making use of these rules, we can rotate the shape 90 clockwise. So okay, let's start from this point, or you can start from any point. That's totally okay. So if I'm starting from this point, now how is this point from center? It's like 1, 2, 3 units up and 2 units to the right. So 3 up and 2 right. How will this orient now? So 3 up, the arrow for up, just see the next arrow. So 3 up will be now 3 right. So this will be for a rotated shape. And 2 right will be 2 down. The next arrow will tell you how it should be transformed. So this will be 2 down. So from center, we will make use of these arrows now. So from center, you have to go 3 right, 1, 2, 3 right, and 2 down. So this point is transformed to this position now after 90 clockwise rotation. We will do the same thing for other points as well. So now if I'm considering this point here, so from center, 1, 2, 3 up, 1, 2, 3 right. So 3 up and 3 right will now be transformed to 3 up will be 3 right and 3 right will be 3 down. So making use of this, from the center, 3 right and 3, so 1, 2, 3 and 1, 2, 3 down. It will be here. The last point, it's 1, 2, 3, 4, 5, 6 up and 2 right. So 6 up and 2 right will be 6 right and 2 down, using the same transformation as we did. So from center now, 6 right, 1, 2, 3, 4, 5, 6 and 2 down, 1, 2. It goes in here. So now joining all these points to make the rotated shape B. Here we get the rotation of shape A after you've done it for 90 clockwise rotation. From the center, -1. So you can use this method for any point, for any type of rotation, if you don't want to use tracing paper. Otherwise, you can go with that. That's totally okay. Now shape B is reflected in the line y is equal to -1. So the line y equals -1 it cuts the y-axis at -1. So that should be the line. So this is the line y equals -1. And you have to reflect this shape B on this line. So if you're reflecting this, now every point, so this point goes in 2 units up, it goes in here, so this will be here, and this point will be, so 1, 2, it's here. Now joining these points to form shape C, that's the reflection of shape B. So here we go with shape C. So now it wants you to describe fully the single transformation that maps shape A onto shape C. So what kind of transformation is mapping shape A onto C. A onto C. What's the relay? Like, how is this being transformed? Well, we see using this line, that is y equals x, we see this is being transformed. This is being reflected on the line y equals x. That's the line y equals x. If I make use of the straight line to have like better thing. So that's the line y equals x. So you see the shapes are reflected on this line. So I will write it's a reflection on y equals x. All right, moving to the next question. Express 0.0724. So 24 is recurring here. You need to express it as a fraction. So here this is like 0.072424. It keeps on repeating. So how can I express it as a fraction? Well, if I take it as like x is 0.07, we have a specific method for changing the recurring decimal into a fraction. So we assume this decimal to be x, and then we take a suitable number and multiply it with x, so that if we shift the decimal to that many places, the idea here is to get rid of the recurring part. So like if I take 10x or 100x, and so if I take like 100x here, that means I'm shifting the decimal 2 places to the right. So now the number will be 7.242424, and it keeps repeating. So after I've shifted it 2 places to the right. Now you see the numbers 2 and 4, they are aligned, so they get cancelled somehow when you subtract them. So that's the idea here. So if I subtract 100x, if I subtract x from 100x and 100x, I get 99x here, equals, now 7.24 take away 0.07. So you have like here, this is 14, take away 7, so there will be 1. So 7.17. You remain with this part. All the recurring part of the decimal will be cancelled here. So x is 7.17 over 99. That's the value for x. Well, we can get rid of the decimal here by introducing a 0 in the denominator. But since there are 2 places, so you need to have two zeros here. So the fraction is 717 over 9900. You can simplify it, but since it did not ask us to simplify, so you can keep the answer the way it is. The next question, a cafe menu has 4 starters, 7 main courses and 5 desserts. Work out how many possible combinations of a starter, main course and a dessert there are. So you can choose one starter from all 4 starters. It can be any one. 7, you can choose one main course and a dessert. So it can be any one of these combinations. So 4 times 7 times 5 will give you all possible combinations of these items. So you just have to multiply them. 7 5s is 35 times 4 is 20, 4 3 is 12. So that's a 140. You have to solve this equation. First, we need to expand the terms on the left side. 6x times 2x gives you 6 2s is 12x square. 6x times 3 is 18x. This is equal to 11x minus 1. So now I'm like taking away 11x and adding 1 on both sides. So minus 11x plus 1. So here also, if I'm taking minus 11x plus 1, so I get rid of this. So we have 12x square plus 18x minus 11x will be 7x plus 1 equals 0. So we don't have anything left over here on the right side. So that's a 0. Now we have a quadratic equation here. We need to solve it to get the value of x. The coefficient of x square is 12 and the constant term is 1. So 12 times 1 is 12. To find the factors of 12 so that it aligns with the middle term here, the 7, I can use 3 and 4. 3 fourths is 12 and 3 plus 4 gives me 7. So now I'm using those factors and trying to rewrite this expression on the left side, making use of the factors. So 12x square, 7x can be split in terms of these factors is 3x and 4x. So I can write like 4x plus 3x plus 1 equals 0. Now considering the first two terms together and the last two terms together. So from first two terms, I can factorize these two terms by taking out the common term. So from 12 and 4, I can take out the HCF is 4 here. And the letter x can be taken out as common. Now what remains here will be 4 3s is 12. So 3x remains and you've taken out 4x. So 1 remains here. And from the last two terms, well, we don't see any common term or a letter. So 1 is the common number. So this HCF will be 1 there. So that's just 3x plus 1 equals 0. Now from these two terms which you have factorized, you can further factorize it. So 3x plus 1 is a common term. So you can take that out as common. So what remains here is 4x plus 1 equals 0. So now you have two of these terms in the brackets. So if 3x plus 1 is 0, then x is a negative 1/3. And if 4x plus 1 is 0, then x is a negative 1/4. So I have these two values for x. So x is negative 1/3 or negative 1/4. So that's the answer. Here is a triangle ABC. Show that x can be written in the form d root e. So like a surd, where d and e are integers. So here I see in the triangle, these are angles are given and the sides are given. We need to figure out the value of x, where we can make use of the sine rule here. So because the angles and the sides are involved and one of them is missing, one of the sides is missing. So if I write like now, labeling the sides to have like easy understanding. So the side opposite to B is B, side opposite to A is side opposite to the angle A is A, and here is the side C. So sine A over A, or I can write A over sine A equals B over sine B equals C over sine C. So A here is 11 over sine, A is sine 30 is B over B. Well, I'm not concerned about this side because we don't need to do anything with that. So just taking C over sine C. So C is X over sine 45. Now to get the value of X, make it as a subject. You times it with sine 45 on both sides. You get rid of this. So we have X equals 11 over sine 30 times sine 45. Now at this point I would say you need to remember the values of sine 30 and sine 45. If you haven't watched my video where I have told you how you can remember these angle values in an easier way, you can check my video there. I will provide you with the link somewhere, or maybe in the description I will give you the link. So sine 30 is half and sine 45 is 1 over root 2. So substituting these values here, 11 over half times 1 over root 2. So this is 11, any number divide by half. When you divide 11 by half, this is like doubling 11. So this is equivalent to 22. 11 times 2 is 22. And then this is times over, times 1 over root 2. So that's over root 2. So if I rationalize this, I get 22 root 2 over root 2 times root 2 is root 2 square. Square and the square root cancels out to have 2 here. So 2 goes in 22 11 times. So we have the final answer 11 root 2. So here we have expressed it in this form where d and e are the integers. Solve this equation to find the value of x. So I'm starting with the left side first. So we have 4x plus 2 over 3. We need to make the denominator same. So we have a 3 and a 5 here. I need to times this by 3 and this by 5. So let me write it here. 5 times 4x plus 2 over 3. Make sure you put them in brackets so that you're multiplying every term with 5. And there is this 3 times 5x minus 6 over 5. This has to be, the entire thing needs to be multiplied. Okay, so I'm just focusing on the left hand side right now. So what did I do here? Oops. 3, okay, this also by 3, this also by 5. All right, so numerator and denominator. So 5 fourths is 20x plus 5 twos is 10 over 15 minus 3 fives is 15x, 3 6 is 18 over 15. This has to be inside the brackets. Okay, so to be more clear. Now there is a common denominator. I can write it as a common denominator. Numerator is 20x plus 10. Now you need to open up the brackets. So minus 15x and minus will be a plus 18. So I can simplify by collecting the like terms. 20x take away 15x gives you 5x, and 10 plus 18 is a 28 over 15. So I've reduced the left hand side. I've simplified it to this form. Now I will take the right side, which is 10x plus 3 over 15. Okay, so now here we see the denominators are same for both the sides of the equation. I can get rid of them by timesing it with 15 on both sides. So this we get rid of the denominator now. So to have only the numerator part, 5x plus 28 is 10x plus 3. Now you can take away 5x on both sides to get rid of this. And then we have 28 equals 5x plus 3. And then taking away 3 on both sides, you have 25 equals 5x. So x is 25 over 5. X is 5. Find the coordinates of the turning point of the graph. So we have this quadratic equation here. We need to find the turning point. To find the turning point, the equation has to be in the form a of x minus h square plus k. So I'm trying to make this equation in this form using completing squares. So if I use the completing squares here, there is a coefficient 5 which I need to take out as a common term. So what remains now is x square plus 4 over 5x, and there is 9 outside here. Now focusing only on this part, we have x square plus 4 over 5x. To complete the square, write it in the squared form. We can write it like the half of 2/5 is half of 4/5 is 2/5. So we can write it like x plus 2/5 square. And then outside it will be square of this. So that's a 4 over 25. You need to take out 4 over 25. But then there is this 5 here. So that has to be there here, because we are taking out of the bracket here. And then there is 9. So 5, 25. So that's a 4/5. So now I will write it here. X plus 2/5 squares minus 4/5 plus 9, right? So that's the 9 fives is 45. If I focus only on this part, so if I write it here, 4 fifths minus 4 fifths plus 9. So here it's like times 5. If I do by taking the common denominator as 5, so minus 4 plus 9 fives is 45. 45 take away 4 gives you 41 over 5. So this part I have calculated it to be 41 over 5. So this is 5 of x plus 2 fifths square, and this will be a plus because the larger term is this one. So plus 41 over 5. So now I have kind of made this equation, the quadratic equation, in the vertex form, so in this form. So what are the vertices now? H and K. So H and K is these terms, right? So, but then you need to change the sign of the H here because it's positive. It has to be like in this form. So H will be a negative 2 fifths and K is the same term, 41 over 5. In a bag, a number of white counters to number of red counters is 7 to 3. In bag B, there are 9 white counters and 2 red counters. In bag C, there are 11 white counters and 4 red counters. Faisal takes at random a counter from bag A and puts the counter in bag B. He then takes at random a counter from bag B and puts it in bag C. Find the probability that there is now even number of white counters in bag C. Well, there are so many things we need to consider here. So there are 3 bags here, bag A, B and C. So which has got like certain number of counters here. So bag A has got white and red, B has got certain numbers here. Now, Faisal is taking one counter from bag A and puts it in bag B, and then takes a counter from bag B and puts it in C. He's just taking one counter from each of these bags. Finally, you need to figure out the probability that now there are even number of white counters in bag C. So let's first try to analyze it using the probability tree. What we can do here. So for bag A, there are 2 possibilities. They are red and white counters. So we have like white, red. How many white counters are? So in the ratio is 7 to 3. So there are kind of like 10 counters in total. So the probability of taking out a white counter from bag A will be 7/10. Okay. And the red counter's probability will be 3/10. Now, assuming that Faisal has taken one white counter from bag A and he's putting it in bag B, what is the probabilities now he will have from what probabilities he can have now? So he will have white and red counters in bag B as well. There are 9 white counters and 2 red counters in bag B. But if he's putting one white counter, he's including one white in bag B. Now, what is the probability of drawing a white counter from bag B? So there are total 10 white counters out of a total of 9 plus 2 is 11 plus 1 is 12. There are 12 total counters now in bag B. And the number of red counters hasn't changed because we have included a white counter. So its probability will be 2 out of 12. Now, assuming that Faisal has taken a red counter first from bag A and he's putting it in bag B, what are the possibilities we have? He can take a white and a red again from bag B, taking red from first bag A. So now how many white counters he will have? Well, he has included now. So now there's one red counter is included in bag B. So there will be 9 white counters out of a total 12 counters. And there is one red counter added here, so there will be 3 out of 12 red counters. So these are the cases. Now we have to figure out what is the chance that there are even number of white counters in bag C. Originally there are 11 white counters in bag C. So bag C has got 11 white. For it to have even number of counters, he has to have one more white counter. So that he has 12. So 12 is an even number. So he needs to have one more white counter. That's the only chance that he will have a even number of white counters in bag C. So in how many ways is it possible to have one white counter in bag C? So he can have one white counter from bag A and putting it in bag B. And that white counter is putting in bag C. So that's the way he can have one more white counter in bag C. Or he can take a red counter from bag A and put it in bag B, and take a white counter from bag B and puts it in bag C. That way also he will have one white counter in bag C. So he can have one white counter in bag C from these two possible options. So we have to find its probability now. So for this rule, it's 7/10 times 10/12 or 3/10 times 9/12. These are the only ways, right? So what is the final probability here? 7/10 is 70 out of 120 plus 9 3s is 27 out of 120. So that's a 97 over 120. That's the final answer. So the chances that he will have an even white counter in bag C is 97 out of 120. The next question is about the indices here. We see all these numbers and the powers are there. We have to find the value of x. Well, we see there are different numbers here and there is a 3 here. So is there a way we can express all of them as the same base? Then it becomes easier for us to manipulate it. So we can express 9, 27 and 81 in terms of 3. So we know 3 square is 9, 3 cube is 27 and 3/4, 3 raised to power 4 is 81. So I can replace these with the base 3. So 9 can be written as 3 square. But then there is another power here already, so we need to consider that as well. This times 27 is 3 cube whole raised to 2 here. So let me make it a little bigger so that it's more clearly visible. And then there is 81, which is 3 raised to 4. And then we have the power is 3x minus 2. That's equal to 1 over 3 raised to 18. Now, which rules of the indices we can apply? Coming from the left side, we know that there is something like this. A raised to m whole raised to n is equivalent to a raised to m times n. So we can multiply these two powers here. Okay, so this will be 3 raised to 2 times 2x will be 4x. Times 3 raised to 3 2s is 6 times 3 raised to, now 4 has to be multiplied with everything here. So 4 3s is 12 and 4 2s is 8. So that's a 12x minus 8 equals, now 1 over 13, 1 over any number raised to power is equivalent to the same power with a negative, same number, same base with a negative power. So it's like expressing the reciprocal in terms of like its power. So this will be 3 raised to negative 18. Now we have all of them in terms of the base 3. Well, we can do something with the powers here. Since on the left side, all these are getting multiplied. So it's of this form. A raised to m times a raised to n is, you can add the powers. When the bases are same and they're getting multiplied, you can add the powers. So if we can add all these powers, which is 4x plus 6 plus 12x, take away 8. This is equal to 3 raised to a negative 18. So here now we see the same bases are there and there is equal sign in between. Then we can equate the powers. So this comes from the rule a raised to m equals a raised to n. This implies m equals n. So I can use this rule here. So I'm just focusing on the powers now because they both will be, these powers will be equal now. So 4x plus 12x is, I will write it directly. So that's 16x, and 6 take away 8 is a negative 2 equals negative 18. So 16x, we add 2 on both sides to have, so you add 2 to negative 18 to get a negative 16. So x is negative 16 over 16. That's a minus 1. So the value of x is a minus 1. The next question is ABCD is a parallelogram. AEFC is a straight line. Prove that ABE and CDF are congruent. Now to show that they are congruent, we have to show the angles and the corresponding sides are of equal length and size. So what can we start with? Here we see these two angles are 90 each. So we can write that. So for triangle ADE, the angle AED equals the angle DFC. They both are 90 degrees. That is given in the question. Also, we see that if I consider, because they are parallel, that's a parallelogram. So this side is equal to this side. The opposite sides are equal. So AB equals CD. So the side AB equals the side CD. They are sides of parallelogram. Just bear with my handwriting. It's not very good. All right. The next thing is, can we find any other common side of the angle here? We know in a parallelogram, if I consider these two are like parallel sides, right? So the AB, so AB and CD are parallel sides, and this is like the transversal, that's the line cutting the parallel sides. So they form this alternate pair here, right? That's a Z-shaped angle. So they will be equal in a pair of parallel lines. So here I get, so I can say the angle DAE, that's DAE, right? Sorry, BAE. So this angle is equal to the angle DCF. Because they form an alternate pair, since it's a parallelogram. So here I have shown two angles and one side, although it's not an included side. So, but that's fine. So I have angle, angle, and a side. Using this property, I can show that these two triangles are congruent. So using angle, angle, side property, I will say that the triangle ADE, let me write it properly, ADE, and the triangle, so sorry, this is ABE, okay, and triangle DCF, are congruent. Okay, next question. Here is the graph of y's f of x. On the grid, draw the graph of y's minus f of x. So for this graph, so what do we need to do here? If it's minus f of x, simply you have to flip it. Like you have to make a reflection of this graph on the x-axis. So we have to reflect on x-axis. because there is a minus f of x here. So every point has to be reflected on the x-axis. So let me use another color here. So this point goes in here now. This point goes up here. So 3 units up will be 3 units down here. And this point will be here. Now connecting all these points using a ruler. So that's a reflection. That's a reflected image of the graph. All right, moving on. Here's a sketch of the graph y is cos x. Point P shown on the graph has a y coordinate of negative null 0.5. So negative null 0.5 is like negative half. So this point P is y coordinate, so somewhere here. So if I try to find its y value, there's minus half here. The graph of y is cos x is transformed to give the graph of y is cos x minus 60 plus 2. So it's been transformed to this form, to this graph. Now you have to transform. The transformation maps point P to point Q. Work out the coordinates of point Q. So we have to find where will this point P be transformed to. Like if we assume it's transforming to point Q, what will be the coordinates of Q using this transformation of the graph? So before we do that, we need to first find the coordinates of point P. So P has we know the y value of P is negative half. So the point P has a y value of negative half. What is its x value? We don't know. What will be this point? So it says that it's negative half. Now we know in the range between 0 to pi, if we try to find its reference angle, using the reference angle for cos, well, so cos of what angle, I'm using like theta as trying to find the angle, is a negative half. We are trying to find the value of theta here. That will be the x value here. Or let me write it as x. Wow, just to avoid any confusion. So cos x is a negative half. So what is x? What angle is x? Which will give you a negative half. So in the range 0 to pi, like I'm talking about the second quadrant now. So in the second quadrant, it will be 180. So we know cos half is 60 degrees, right? Before that, so cos half is 60 degrees. So cos of 60 degrees is half. So cos of what angle is negative half? So if it's using the reference angle, it has to be like x is 180 minus 60, right? In this range. So that will be 180 minus 60 has to be 120 degrees. So for cos negative half, the angle should be 120 degrees, right? So I figured out the x coordinate of the point, which is 120. Now what do we have to do? We have to find the coordinates of point Q using this transformation. So here we see, for this transformation, what is happening here? If I try to analyze the transformation, the x value or the x coordinate is being shifted 60 units to the right. So 60 right. Why? Because it's a negative 60. So on the x coordinate, it's like the opposite of what's given here. So we move like plus 60. And on the y, we go up by 2 units. So this is 2 up. So now using this transformation, we figure out the point Q. So originally it was 120 and you add 60 to it. And for negative half, you add 2. You go up by 2 units. So the point will be 120 plus 60 has to be 180. and you take away half from 2 to get 1.5 or 1.5. So these are the coordinates of the point Q. It's 180 and 1.5. All right, the next question is about the surds here. We have this form, this rational, the surd in the form of a rational number. And then we have, this is in the form a plus b root c over d, where a, b, c, and d are integers. So you have to express this in this form. You have to express the surd. So we have to first rationalize the denominator here. So using its conjugate, so the conjugate of 27, root 27 plus 4 will be root 27 minus 4. So writing this here again, root 3 plus 1 over root 27 plus 4. Rationalizing it, so root 27 minus 4 over root 27 minus 4. Then I have to, so let me put them in brackets so that we don't miss out any term here. So the numerator will be root 3 times root 27, and then root 3 times, so we multiply out every term here, and then minus 4 root 3, so this times this, and then 1 times root 27 will be root 27, and then 1 times negative 4 is a negative 4. Now in the denominator we have root 27 plus 4 times root 27 minus 4. So this is of the form a plus b times a minus b. So using the rule, this is equal to a square minus b square. So it's in the squared form. So this will be root 27 square, if that's a, and minus b square. B square is 4 square. So this will be root 3 times root 27 minus 4 root 3 plus, let me write it the way it is before simplifying anything. I will just focus on the denominator here. So root 27 squared, the square and the square root cancels out to have 27 remaining here, minus 4 squares is 16. So we have 11 in the denominator. So 27 take away 16 is an 11. And what about the numerator? Now we can manipulate the numerator here. Well, you can write root 27, like this is 9 threes is 27. So I can write it like, you can take out 9 from the square root to have 3 root 3. Is there anything else we can do? Well, we can write root 27 as 3 root 3. So there is a root 3 already here, times 3 root 3. Minus 4 root 3 plus, again you can write 27 as 3 root 3 minus 4. Let me extend these. Alright, so now what do we have here? So root 3 times 3 root 3. So root 3 times 3 root 3 will be, we have 3, and root 3 times root 3 is root 3 square, which is just 3. So that's equivalent to 3 times 3, that is a 9. And then minus 4 root 3 plus root 3 plus 3 root 3. You can you can consider them as like terms. So you're left with a negative root 3. And there is a minus 4 here over 11. So 9 take away 4 gives you 5 minus root 3 over 11. So we have simplified this in this form, where it's of the form a plus b root c over d. Did it ask to find the values of a, b, c, d? Well, it didn't ask. So just we need to write it in this form. So that's the final answer.